partial sums of a geometric series, and I have a riddle for you at the end. This is 14.3c. We're up to 10 previous videos for this chapter. If you haven't seen them and you become lost or confused, it's because you missed something, and there's links in this description so you can watch those. We can find partial sums of a geometric series. A geometric series is a series that's associated with a geometric sequence. We can find the sum of the first n terms of a geometric sequence, S sub n. So this would be the sequence, and we'd have our first term, a sub 1. Then to get the second term, we would multiply it by the common ratio, right? To get the next term, we'd multiply it by the common ratio squared all the way to the nth term. It would be the common ratio to the n minus 1. We can multiply both sides of this by r. We multiply this side by r, and we multiply all the terms by r. And subtracting the second equation from the first equation, we get this. When we factor it and divide both sides by 1 minus r, guess what's going to happen? We get a formula for the first n terms of a geometric series. And that brings us to our theorem. The sum of the first n terms of a geometric series is given by this formula. We have S sub n is going to equal the quotient of a sub 1 times 1 minus r to the n and 1 minus r. We use this to add a specific amount of terms. It involves a fraction where we subtract the ratio, or a power of the ratio, from 1. And this formula can't be reduced, so we use it as it is. Okay? Another version of this formula is this. So take a look at the one above it. Okay? So this is another version of the formula. But if r is equal to 1, we have a 0 denominator. See? If that's a 1, we end up with a 0 denominator. And the geometric sequence would be a sub 1, a sub 1, a sub 1, a sub 1. And that's also an arithmetic sequence. So we can use the formula for the arithmetic series that we learned in video 14.2d. That means we'd have a 1 here, wouldn't we? So that'd be a half times 1 plus 1. So it'd just be a 1, wouldn't it? This simplifies to this, okay? So we're going to use this formula. We can find the sum of the first 6 terms of the geometric series, 3 plus 6 plus 12 plus 24 plus and so on. We know this is the information that's given. A sub 1 is a 3. We can see that. N is going to equal a 6 because it's the first 6 terms. R is going to equal 6 divided by 3, which is a 2. So our common ratio is a 2. Then using the formula from the theorem, this guy, we put all this information into the formula, and we have S sub 6 is equal to, see, the 6 was the n, 3, that's a sub 1, times 1 minus 2 to the 6. And it's going to be divided by 1 minus 2. That is going to simplify to a 64, the 2 to the 6th power. That means we have 1 minus 64, which is a negative 63, isn't it? 1 minus 2 is a negative 1. When we do 3 times the negative 63, we get negative 189. And we have a negative 1. When we do the division, we get a positive 189. So the sum of the first 6 terms of this geometric series is 189. Okay? See how I got that? We plugged in what we knew. All right? We can find the sum of the geometric series. We did this. The sum, we know it's going to go from 1 to 5, and this is the sum of the quantity of a half to the n plus 1 as n goes from 1 to 5. So we're going to find the first few terms. We're going to put a 1 here because it goes from 1 to 5, and we could do it all the way to 5 if we wanted to, but I just did the first few. We have a half to the first plus 1, half to the second plus 1, half to the third plus 1. So we end up with half to the second power, half to the third power, half to the fourth power, which means we have 1/4, 1/8, 1/16. So we know a sub 1 is a fourth. We know n is equal to 5 because it tells us right here on top of the sigma. It's a 5. We also know that r is a half because 1/8 divided by 1/4 is a half. So using the formula from the theorem, we plug this information in, and we end up with our a sub 1 is a fourth, okay? We've got our n is a 5 here. We've got our r as a half, and it's going to be to the 5th power, see? Half to the 5th power is 1/32. We subtract 1 minus 1/32, so that's, we could look at it as 32 32 minus 1/32. That's going to give us 31 32, isn't it, for inside the parentheses? 1 minus a half is a half. We're going to multiply a fourth times this, and when we multiply it, we end up with 31 64ths. So the sum of the series is 31 64ths, see? Okay? And we won't have a geometric sequence if r equals 0. If r equals 0, we're going to have a sub 1, a sub 2, and a sub 3, and we're going to have a 1 times a 0 to get to the second term. That means that would be a 0. And then we'd have 0 times 0 to get to the third term. So that's not a geometric sequence, okay? And we can find the sum of the first 8 terms of the geometric series, 1 plus 3, so that'd be 3 to the first power, wouldn't it? Plus 3 to the second power, 3 to the third power, plus 3 to the fourth power, and so on. So we know a sub 1 is a 1. We know n is an 8 because it says the first 8 terms. We also know r equals 3. 3 divided by 1 is a 3, right? 3 squared is a 9. 9 divided by 3 is a 3, okay? So using the formula from the theorem, we take our information from the box, we put it in, and we know n is 8, so we have s sub 8. We know a sub 1 is a 1. We know r is a 3, so we have 3 to the 8th power, and we have a 1 minus 3 down here as the denominator. 3 to the 8th power. On a calculator, if you don't know, you hit 3, the y to the x button, the 8, and then the equal sign, and that'll give you a 6,561, okay? 1 minus 3 is a negative 2. Now we have 1 minus 6,561, which is going to give us a negative 6,560. We're going to divide it by negative 2. That's going to give us a positive 3,080. So the 8th term is 3,280. Okay? Let me back up a little bit. All right? So here's the riddle. And it's 200 or 300 years old. It's an English nursery rhyme. It's, as I was going to St Ives. As I was going to St Ives, I met a man with 7 wives. Each wife had 7 sacks. Each sack had 7 cats. Each cat had 7 kits, for kittens. Kits, cats, sacks, wives. How many were there going to St Ives? So they're insinuating that we're going to count the sacks too, okay? So to find a sum for the geometric series of all he met, we have the man, that's 1, that's going to be our a sub 1. His wives, there were 7 of them, so that's a sub 2. The sacks, because we're counting those too, would be 7 squared, that's our a sub 3. The cats would be 7 cubed, that's our a sub 4. And the kittens would be 7 to the 4th power, that's our a sub 5. So we know a sub 1 is 1. We know n is a 5 because we're going up to there. We also know r equals 7. 7 divided by 1 is 7, okay? So using the formula from the theorem, we plug this information in, and we have s sub 5 equals a sub 1 is a 1. R is a 7, so we've got 7 to the 5th power. 7 to the 5th power is 16,807. We're going to subtract 1 minus the 16,807 and get a negative 16,806. It's multiplied by 1, so it's still that, right? 1 minus 7 is a negative 6. Now we divide, and we get 2,801, but there's the narrator too, isn't there, going to St Ives? So that would be 2,802. Now, that's if all were headed the same direction towards St Ives. But the word met makes this riddle ambiguous. It's a trick. there's a connotation that the narrator met them as they walked away from St Ives. So that means if they're using this word met that way, which that's the way the riddle was supposed to be, it's supposed to be a trick, he was going to St Ives, they were coming from St Ives in the opposite direction, and that's how he met them face on. So the answer really is 1. He was going to St Ives. These people were heading towards him, and he met them. It doesn't say anything about them walking up beside him and meeting him. So if your teacher ever asks you about this riddle, you know the answer is supposed to be 1, okay? But it is a geometric series to figure it out, okay? Our very next lesson is going to be 14.4 videos. They're going to be all about infinite geometric series. So the very next lesson is convergent geometric series, 14.4a, and we're going to determine if a geometric series has a sum, okay? So I hope you liked the riddle, and I hope this was helpful. And I will see you next time. Keep trying. I'm proud of you. Bye.